All right, what we got is right in front of you. You should have two pieces of paper. You have a big old blank quadrilateral hierarchy, right, that we're going to fill out. If you remember that I told you that literally is the last question, the last page of the test. So here is the fourth page of the test. There is absolutely no way that we could fill this all out today. I mean, we could. It would just melt your brains of how much information that I just shoved down your throat. So we're going to do a little part of it. And then there's another worksheet about kites and trapezoids, so that's kind of what the message is today. But here's what I want you to do with this hierarchy that's in front of you. Please put the word correct right here, because you're going to have quite a bit of these hierarchies handed your way to where I ask you to fill them out. This is the one where you know that this has got all the right answers on it, because we're going to fill this one out together. Does that make sense? All right, so this is the correct one. And don't let it overwhelm you. If you truly study this stuff, it really isn't that big. It starts at the top. I want to know the definition of a quadrilateral. We know the definition of a quadrilateral. What is the definition of a quadrilateral? Four-sided polygon is correct. So you can pause the video if you need to, but I'm going to go really quick. Oh, man. On your homework, you know, it asks a good question. You know, a lot of people, I'll talk about homework here in a second, though, realize, remember convex means like it can, like, it doesn't dent in, so doesn't non-convex things like have a dent in it? Who was the answer besides quadrilateral of which one of the quadrilaterals could be non-convex? Who was the only other guy besides the quadrilateral? The kite. And you know why? The kite is the oddball in the family. That's what we talked about last time. What doesn't the kite have that everybody else in the family is going to have? Parallel lines. It is impossible to draw two guys parallel to each other, right, to have a set of parallel lines and put a dent in your guy and still have four sides. Would you believe that that has five sides now in that case? So the kite was the weirdo. Speaking of kite, let's go get his definition. He's the hardest one. See if you can tell your neighbor real quick what that definition is. Like that? Would you believe that a kite has two distinct pair of consecutive sides equal? You can abbreviate how I abbreviate it. If you can't fit it all on that line, that's okay. You know, I get that. You know, just try to squeeze it all in there. But it's got two distinct pair of consecutive sides equal. Then they want to know if a kite has any symmetry lines. So what do you think about, like, if I was to do this? Does this look like it would be a symmetry line? Is everything above that blue line like a mirror image of everything below it? Yeah, probably not. What if I did it like this? Would you think that everything on the left side of that guy is a mirror image of everything on the right side? That is going to happen. So when it comes to these symmetry lines, here's what you got to tell me on the test. First, you got to tell me how many there are. Answer, one. There's one symmetry line, right? Then you have to tell me where he is exactly in the words that I give it. This one symmetry line for a kite is through the ends. So you got to say, yo, I got one symmetry line, and it's through the ends. I will tell you what the ends are here in a second. So where are the ends of the kite? I have this kite drawn off to the side. You don't need to have it. It's just kind of like a little visual example. The ends are where the two sides that are the same touch each other at, where two sides the same touch. So give me an end of kite A, B, C, D. Who's one of the ends? B. Don't two sides the same touch each other there. And who's the other end then? D. And if I was to connect those with a line that goes through that, would you believe that that is the symmetry line in that case? The symmetry line goes through the ends. Cool. I'm going to draw in this diagonal over here also. So there's like one of the diagonals. Let me change colors. What would you think fanciness-wise it looks like with those diagonals? Do they look like they are perpendicular? What do you think? If you was to take a guess, do they intersect at a 90? Yep, that's all that's going on. That's the fancy part about them, that they are perpendicular. If you want, you can put that symbol. Do you remember what the symbol looks like for perpendicular? What's that look like? Upside down capital T. So I don't care if you write out the word perpendicular or if you just put that symbol. But those dudes right there totally intersect at a 90. Out of the other fancy things, I just want to talk about it, even though it's very strange to us. They do not bisect each other. It is totally true that this red diagonal does cut the green one into two equal pieces. That will happen. But my question is, does it work the other way around? Does the green one cut the red one into two equal pieces? So when I say bisect each other, it has to be a two-way street. The red one cuts the green one in half, and the green one cuts the red one in half. That's not happening, right? And they're definitely not the same length. So the only thing that's fancy about them is they are perpendicular. And then a property that we're going to do is that the non-end angles are equal. The non-end angles are equal. The non-end angles are equal. So if B and D are the ends, which they are, would you believe that A and C are the non-ends, right? They got to be the same. That is a property. And that's enough of this hierarchy for right now. Like we've only done 2 and the brain is starting to get overwhelmed. Let's go to the practice worksheet and kind of like do some problems about kites to get a little more in depth with them. So on number 1, they say use your geometer to draw kite John with ends O and N. Mark the kite by definition and draw in any symmetry lines. Remember, there's not a kite on your geometer, so you're just going to have to like take your straight edge and do your best job of making one. It's not going to be perfect, you know, but give it a shot. So since O and N are supposed to be the ends, I'll label them. And then that means I got to go around the clock and spell the word John also, so you have to watch that. And to mark it by definition, which we are, it's not that you don't know what that is, we're just not doing it, you know. It's like you mark a kite by its definition. They said draw in any symmetry lines. Sweet. This is brand spanking new for you. Grab the hierarchy. That's the whole reason why this is on the test. I would do that first. When I hand you the test on test day, there's 4 pages. That's the 4th page. I would do that one first, you know, because when you put all that stuff in there, if it's correct, it's going to answer every other question on the test because they want to know where the symmetry lines are. Cool. Look it up. Does a kite have any symmetry lines? Yes. Where at? Through the... So we'll draw that dude in. And because he's a line, we do need to like put arrows. So it's not like a diagonal, you know, it's going to go through the kite and put some arrowheads on him. All right, put some arrowheads on him. So they said draw in any symmetry lines. So that's nice. So that was John. Number 2, they ask you to draw the kite Cena. Mark all that stuff, what it says. Work with the neighbor. Why don't you pause the video and get that done real quick. There's mine. Don't forget you got to mark him by the definition. Now, it doesn't matter where you put the single ticks and the double ticks, but you got to have a set of singles, got to have a set of doubles. They say draw in the diagonals and then mark if there's anything fancy about them. Well, it's still very new to us, right? So I'm going to draw in both diagonals. There's a different color than red. There's a green one and a blue one here. According to your hierarchy, where we have diagonals as a blank, what was fancy about them, if anything? They are perpendicular, so shouldn't we put that right angle box? Are you okay with that? You just got to put it once on that situation. But the diagonals of a kite are perpendicular. Cool. All right, those are pretty basic. Then they say this. Ooh, here's my question. Look at that shape. Is that a kite? This is definitely a kite, even though it's not marked. They totally tell us right here, and you know some of us are very guilty of just like looking at pictures and not reading. So that's a kite. I like it. We figured that out. Who's the ends? Is it W and Y or is it X and Z? So because our hierarchy says that non-end angles have to be equal, are these 2 angles right here, guys, equal? Yes or no? There's no way that those are the non-ends then. It's kind of backwards. Those have to be the ends, right? Because the non-ends, which are these guys, Bing and Bing, shouldn't those be the guys that are the same, right? So since these have to be the same, those are the ends. Cool. Please work together and find the measure of angle Z. So because this is a quadrilateral, shouldn't all 4 of the angles have to add up to be 360? And you could add these together and get 140, right? And then take 360 minus 140, and that's 220. And then why are these the same, though? Why are those the same? Non-end angles are the same, or you could use the fact that there's symmetry, however you wanted to say it, right? So you could divide it by 2, and each one of those is 110. That is correct. Either which way you guys wanted to describe it is fine. I'm going to show you how I'm going to do it, and you decide what you should probably do on test day of how to do that. Since they want me to find the measure of angle Z, I'm going to make up a variable for it. I'm just going to call it, I'm not going to use X since they're using the letter X, so I'm going to call it A. Got one question for you. If this is A, how much should this one measure right here? A as well. I'm going to add all of them up. That's 1A plus 1A is 2A plus 80 and 60 is 140, and that should equal 360 degrees. All right? Then I will subtract the 140 over and realize that that's 220. And then I will solve for A and get A equaling 110. And you make your decision, guys. If you think showing the algebra behind that is what I would like you to show me, or if you just do it all in your head / calculator. Your choice. You know me well now in January. So whatever you think is more important. But that was good. I like the problem solving. But the math judge is coming back strong this chapter. So he likes stats. Cool with that? Okay, let's keep rolling. ABCD, question, is he a kite? What do you think, yes or no? Yeah, boom, 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 boom. Marking stuff. They say find all this junk. This is going to be a lot of homework questions. I won't lie to you. This is one of the most missed problems on our tests, and I don't understand why. It's because people don't buy into this hierarchy right away, and then they get very, very lost. So here's how I think is a great place to start. My ideal starting spot is right here. Does anybody know how those diagonals relate to each other when this is a kite? Anybody know that angle measure? That is 90 degrees because those diagonals are supposed to be perpendicular. And then what you got in this picture is, boom, you got you a green triangle, boom, you got you a pink triangle, you got you an orange triangle right here, and then you got that other white triangle that I'm not even going to highlight. It's 4 different little triangles going on. You can roll however you want to roll. I'm going to go with angle measures. I'm going to find all the angle measures that I could possibly find. So here's an obvious one. How much is this guy right now? 90. Same with this one is 90. Same as that one is 90. Cool. Use the green triangle now. Let's pick on that green triangle. Here's the 90. This one is 67. Could you find this third angle in that triangle? How much? 23 degrees. How do you feel about that? All 3 angles should add up to be 180. So here's my question. Does anybody, like if this is 67, does this have any symmetry lines either? Like does the kite have any symmetry lines? Yes, it does. What do you think? Is this guy a symmetry line right here, this pink dude? Nope, that doesn't go through the ends. How about right here? Isn't that a symmetry line? If this big dude up here is 67, how much should this one be right stinking here? 67 degrees, because of symmetry. And then if this is 23, shouldn't this little guy right here be 23? Are y'all cool with that? Okay, rock this orange triangle. See what you can find real quick. What did we get for the orange triangle? This is 39, this is 90. How much is that one? 61 degrees. Is that okay? You see how those are not the same. There's not symmetry going on. Is it 61 or should it be 51? Right, yeah, 51. Thank you. Okay, cool, cool, cool. Oh, that's weak. And then by symmetry, shouldn't this guy be 51 degrees? And how much is this guy right here? 39. That's all the angle measures that I could find. Let's start rocking some side lengths. I'm going to go with the orange triangle first. It is a right triangle, my friends. So the Pythagorean theorem should hold. This side is 5. This side is 12. And I am missing the hypotenuse. Anybody know what that is without doing any work? That is the 3rd most popular right triangle around. That's the 5, 12, 13. So down here, see this green machine right here is 5? Guess how long this guy is right here? That's 5 by symmetry. So you got yourself another 5, 12, 13 right triangle in that case. And then check out the green boy. 4, 5, boom! Is that missing side? 3. Because 3, 4, 5 is the most popular right triangle around. 3 or not 3? That can't be 3. Why can't it be 3? Because if you had a 3, 4, 5 right triangle, who should be the hypotenuse? 5. So that's not going to work. So what we'll do is we're going to do the right thing. Now, we're not going to make up variables for things if we don't have to. We'll do the Pythagorean theorem. Let's do 4 squared plus 5 squared should equal, instead of making up a letter for that, let's call him what he really is. He is the distance from A to B squared. I can see that's just the distance from A to B. So do the Pythagorean theorem, please. So I got myself down to 41 equals the distance from A to B squared. So then what the heck does the distance from A to B equal, dear friends? square root of 41, which is not, not a perfect square, so we're going to leave it like that. We put them in the picture, square root of 41. What do you think? Should I do that Pythagorean theorem all over again right here, or do I know how long this side's supposed to be? Dude, it's a kite, you know? It's like, come on now, square root of 41. You're cool with finding everything that you possibly can. So it is now your turn to please pause the video. Please put the letter U right here also. I didn't put that on your worksheet, so throw the letter U right there and give the video a pause and try to find everything that you possibly can. I'll get you started. Start, boom, right here where the diagonals intersect, because this is a kite. It really doesn't matter what order you go in. You just got to find all the stuff that you can. I usually roll with all the angles, so I got my 90s right away. Here's the 43. Based on symmetry, that's got to be a 43 because, dude, there he is. Some people, if you highlight the symmetry line, that really helps a lot of people, you know, so there's the symmetry line right there. And then since this is 43 and that's 90, that's got to be 47 degrees. Please don't go with what the picture looks like because that it's really not looking like it's 47 degrees. We're just going to go with what the math is. And then shouldn't this one be 47 degrees? Are you okay with that? Then here's a 20-degree angle, so that's got to be 20 by symmetry, and then that means this has to be 70 degrees and 70 degrees to get them all to add up. You guys cool with all the angle measures? Then side lengths. Here's probably the most forgotten thing, to throw a 12 right there and to throw a 5 right there. It's like it's so obvious. It's like, oh yeah, duh, I forgot to even do that. And then you see this little 4 right here. It's kind of hard for some people to see. Here's the right triangle in blue. One side is 4. This side is missing, and the hypotenuse is 5. Any guesses on what that dude's supposed to be? 3. Once again, don't look at how they look. You know, it's like the 3 is way longer than the 4. Go with the math. And then since this is a 4, shouldn't that be a 4 based on symmetry? And then I got to find this dude, so I don't have a special rule for him. So 4 squared plus the distance from U to S squared should equal 12 squared. And that's 16. That's 144. Subtract that over, and that is a 128. Is that right? Check me out. Is that 128? And then you square roots. 128. And put him in the picture. So kites, man. It's all about knowing what's true about their diagonals and their symmetry lines. That's the whole purpose of why I'm having you basically memorize this hierarchy, because every basic question is about diagonals and symmetry lines of these shapes. Let's move back to the hierarchy and do a couple more shapes. We're just going to get some trapezoids down. Would you please get that definition down all by yourself? Pause the video, give it a shot. See if you can. This definition does get missed a little bit. That one magic phrase that makes it all happen. It's not just about having one pair of parallel sides. What's the magic phrase? It's got to have at least one pair of parallel sides. At least one pair of parallel sides. To kind of make this go a little quicker, talking symmetry lines, there will be none. Right? There are no symmetry lines for just a plain Jane trapezoid. Like if I drew this guy in right here, not everything on the left side is the same as on the right side. If I drew that guy in there, not everything above it is a mirror image of below. There are none. What's true about the diagonals? Let me just kind of draw them in to show you what's going on. If I could just get there. Maybe not. Let's just talk about perpendicular. That's the one that's easiest for you to see. If I drew those in, does it look like they intersect at a 90? What do you think? Nope, that's not going on. Does it look like they cut each other into equal pieces? Not really. Does it look like there's the same length? Maybe on this one they're kind of close, but they're not actually the same length. It doesn't have any of those three things going on. No fancy things. So what would you like to put for the diagonals? Nothing fancy, right? It does have diagonals, but there's nothing fancy about them. And out of all 32 blanks on this page, this property right here is one that gets left empty or blank or like wrong a lot on the test. It's a weird property. It's that consecutive angles between parallel sides are supplementary. Consecutive angles, you can abbreviate just like I do, between parallel sides are supplementary. We'll talk about what that means in a second. So I do want you to number this on your paper. Let's put these angles as 1, 2, 3, 4. Let's just kind of talk about them. And so far, this chapter, I think we've really kind of understood what consecutive was about. We've talked about it a couple times. Doesn't consecutive mean like right in a row? You know, if I won consecutive national championships, it's right in a row. Well, you don't have to draw all these arrows, but would you believe that 1 and 2, if I was to go around the clock, those are totally consecutive angles. They were right in a row. And so is angles 2 and 3. They're right in a row if I was going around the clock. And so are angles 3 and 4. And so are angles 4 and 1. Any which way you go around, like the two are consecutive to each other. But it's this between parallel sides that confuses people. Not only do you have to be consecutive angles, you have to be between parallel sides. So what do you think? Gut feeling, angle 1 and angle 2. Even though they are consecutive angles, are they between the pink side and the green side, or are they on the same side? What do you think? Aren't they both touching that green parallel side? Are you with me on that? Those are not between parallel sides. But what would you think about 2 and 3? Does one of them touch the green parallel side, and does the other one touch the pink parallel side? Those are between parallel sides. So since those are consecutive angles between parallel sides, like if this was 100 degrees right here, can you figure out what that one is? I guess I need help. What does supplementary mean again? They add up to be 180. So if this is 100, what's this one got to be? 80 degrees. Watch this. Are 4 and 1 also consecutive angles that are between the parallel sides? One's touching the pink guy, the other's touching the green guy. So if this one was 90 degrees, how much has that one got to be? 90 degrees. These two have to add up to be 180, and those two have to add up to be 180. But look at these. Those don't. Those do not add up to be 180 because even though they're consecutive angles, they're not between the parallel sides in that case. So let's do one more shapey McPoo, and then we'll go back to the worksheet. Please get that definition of isosceles trapezoid down. You don't have to get it all on the line. You can kind of like maybe put a little bit under. It doesn't all have to fit. So it's got at least one pair of parallel sides and base angles equal. Again, it doesn't all have to fit on that line if you can't fit it on there. It's just got to be up there by the definition. Symmetry lines, we really should do like what we did last time next time. You know, it's like, but there, we talked about it. Like isosceles trapezoid does have a symmetry line. My question is it right here? Is that the symmetry line for this guy? No. Isn't it more like right here in this case, like everything on the left side the same? So I'm down with the fact that we know where it's at. How do we state it? First, again, you got to tell me how many it has. How many does it have? 1, and here's where it's at. It's the perpendicular bisector of the bases. So you'll say 1, and then put a colon, the perpendicular bisector of the bases. So let's talk about what that means. We have talked about it a couple times. Remember, in a trapezoid, the bases are the parallel sides. Are you cool with those being the parallel sides? Help me with this again. What does perpendicular mean? Goes through it at what angle? 90. And bisector means it cuts it into 2 equal pieces. So do you see like this? You see that blue line right there, doesn't it totally go through both bases at a 90, right? It's perpendicular to it. And it cut this guy into 2 equal pieces, bing, bing, and it cut that guy into 2 equal pieces. Would you believe they're also different? Like if this whole top thing was 10, doesn't this go, 5 and 5? But this bottom one isn't 10 units long. It could be like 14 units long, and wouldn't that go 7 and 7 in that case? It's the perpendicular bisector of the bases. And we'll deal more with that on our worksheet. There is something fancy about the diagonals. They are equal to each other. The diagonals of an isosceles trapezoid are equal to each other. So in my picture right there, that red one is the same length as the green one. I should say blue one. A little colorblind this morning. And then the property of these guys is that the legs are equal. Just like in an isosceles triangle, it's got like 2 equal sides, you know. These dudes right here are called the legs. They're not the bases. Those are the legs. They are equal. I will answer this question right now. Mr. Fonstill, when we mark an isosceles trapezoid, should we put those tick marks? If it says mark it by definition, does this have anything to do with the definition, or is that a property? So definition is the arrows and the arc marks. You with me on that? Cool. Good. So let's go do some questions about trapezoids. Number 7, what are we drawing? Isosceles trapezoid or plain Jane trapezoid? Plain Jane. So do your best to draw something like this. Don't use the isosceles trapezoid because he's going to confuse you more than he's going to help. Get your bases in there. JO is the base in segment HN. Remember, when you go around, it's got to spell John, so you got to make sure you put the H's and the N's in the right place. So I marked it by its definition. Let's draw in each diagonal, because that's what it told me to do. So there is a bad job there. Let's try that, dude. Green one, blue one, and then just write in there or mark on there what's fancy about them. You're probably going to have to look that up for the first few days until you get a habit down. This is a trapezoid. Go to your hierarchy, look at what we put for the diagonals, and see what's fancy about them. You could put some perpendicular by marking it. You should do some bisecting by marking it. You could do some equal, or sometimes there's nothing fancy. What do you want to put? There is nothing fancy about these. So, nothing fancy. Cool. Why don't you start on number 8? Pause the video, get that one done. Trapezoid. So we're drawing that isosceles trapezoid for the next guy. We got these bases, so EN. And so it's supposed to spell Cena, so there we go. Make sure you got it marked by definition correctly. And then it says draw in any symmetry lines. So if you would grab that hierarchy and look to see where the symmetry line's supposed to be. The weirdest part is most students are just going to draw this. And I'd be like, that's not good enough. Isn't the symmetry line supposed to be the perpendicular bisector of both bases? So you've got to put the right angle box both times, and you got to split them up both times. Questions on that dude right there? Drawing in the symmetry. Cool. Let's keep rolling. Use your geometer to draw that guy. I'll let you give that a shot. Pause the video and then check back to see how you did. There's the isosceles trapezoid. Make sure we got all the letters in the right spot. They say draw in those diagonals again. So there's a green dude, and there is a red dude. And there is something fancy about these diagonals. What's fancy about isosceles trapezoids diagonals? They are equal, so we'll put the tick marks on there. We'll put the tick marks on. Cool. That's what she should look like. Just a few more, right? We got us some questions like this. I'm going to do more than this because the homework's going to say find everything that you possibly can. So instead of just finding the measure of angle D, let's find everything that we can. First thing we'll start with shape recognition. What shape is that guy, y'all? Excellente. I would give you a little push in the right direction. It is an isosceles trapezoid. I would find this guy first. Look to the hierarchy, look through them properties. Maybe you even got to jump all the way up to a trapezoid, because question, is this a trapezoid also, right? Check that out, see what we can do. What is the property of a trapezoid that we need to use here? That the consecutive angles between parallel lines are supplementary. So these are definitely right in a row, and they are between the parallel sides. If this is 125, how much is these? 55 degrees. Does that make sense? That we had to use the trapezoids property. Awesome. Then, how much should these one be? 55 degrees. You could justify that a lot of ways. You could say, well, there's symmetry right here. You could go, their marks the same, you know. So if this one's 55, shouldn't that one be 55? How much does these one got to be? 125. That's where you could definitely use symmetry on it. Another thing that we'll learn is, you know, isosceles trapezoids have base angles equal. Yes, these can be the base angles, but so can these. Remember that the bases are the parallel sides, so those 125s are also base angles. You know, it's like they got to be the same. Cool. Shape recognition, 12. Trapezoid or isosceles trapezoid? Cool. Find everything that you can. He's just a trapezoid. All right? Find everything that you can. What did we find? Anything that you could find for sure? You're like, yep, we got this. What'd you get? Measure of angle L, right? This guy right here and this guy right here, are they consecutive angles, and are they between the parallel lines? Would you believe one of those touches the orange parallel line, the other one touches the green parallel line? So if this is 40, how much this? 140. Cool. I like it. Question. This guy. Boom. Is he 40 degrees? Why? Some people said yes. Why? We have no real evidence to prove that that's 40. So this is all we can do. When the homework says find everything that you can, it doesn't mean that you're going to find everything. It's find everything that you can. Is that okay with that? All right, and then what do we got here? This guy right here, I'm calling it, so we'll make sure he's an isosceles trapezoid by drawing him correctly by definition. Nice. It's got bases of 12 inches and 18 inches, so we'll make the short one short and the long one long. Ooh, 45-degree base angle, so okay, we'll put those in, 45, 45. And they want us to find the area of that shape. Well, we'll drop in some height since we'll need that height. So let me kind of get this rock in here. Here's a height. We also kind of talked about dropping both heights in an isosceles trapezoid because that's going to help us. So if I call that H, I don't have him, but the idea, especially now that we learned that there's some symmetry involved, we know if that dude's 12 and switch colors, that that dude's got to be 12. And if this whole mamma jamma is 18 and this much of it is 12, that means that there's 6 left over for both parts. And because they got to be the same, each one is going to be 3. But still, to find that height, people struggle because they don't have that hypotenuse of that right triangle. We don't need that hypotenuse because we know this angle is 45 degrees. And in this triangle, since this is 90 and that's 45, that means this third angle right here has to be 45 degrees. And that means since 2 angles are the same in a triangle, that triangle is isosceles. And these 2 sides right here should be the same. And if this is 3, doesn't this guy have to be 3? So we have the height already by using that isosceles triangle thing. So here's our formula, and then we'll sub in. The height is 3. The 2 bases are 12 and 18. And I'll just kind of clean that up. That's 1/2 times 3 times 30. And if we punch that in, I get 45 for that guy in that case. So 45. And then the label, inches squared. So cool. Let us know if you have any questions, man. Have a good one.